So we have learned the basic photovoltaic. So the theory will be meaningless if we don't apply the technology to the technology that is needed by the community. So this is the first attempt of combining the theory with the application in farming. So I focus on the aquaponics farming system. This is very simple, which we have learned before this, but assume this as a revision. So again, solar cell is a device that converts sunlight to electrical energy. True or not? Betul? Solar cell is a device that converts sunlight to electrical energy. Betul? So I don't want to see any answer, any of your answer in the final examination which say that solar is a device that converts sunlight to electrical energy. It's solar cell, not solar. An arrangement of few solar cells in series or parallel is called solar panel. Correct? Various types of solar cell technology, exempli gratia. E.g. bukan ini example, exempli gratia. Silicon based, gallium arsenide based, cadmium telluride based, perovskite based, dye based, and quantum dots based. We have so many technology. Some of them are not listed in this sentence. Well, the silicon base is commonly used and easily obtainable from local stores. So from solar cell, we could connect them in series or in parallel, and they become solar panel. And when we connect the solar panel in series or parallel, we got solar array, bigger type of solar array. Assembly of solar panel is called solar array. Well, let us see the silicon-based solar cell. Revision only. The device needs to absorb high intensity of sunlight to initiate electricity. High intensity, which means we only could absorb light at which time in Malaysia? Dah tulis. Okay lah. So in Malaysia, we only have circa 4 hours. CA is circa, or known as approximately, of intense sunlight could be harvested per day from 11 AM to 3 PM only, if we use the silicon-based technology. What happened to from 7 to 10? The energy is wasted. It cannot be used to excite any electron in the silicon-based. Same goes for from 4 PM to 7 PM. We cannot harvest that energy. It is wasted, cannot be converted to electrical energy. So what happens if we have clouds or rainy day? No significant output will be generated during cloudy day or rainy day, because we want high intensity sunlight. Even though it is already 12 PM, and if we have cloud or rain, so we cannot generate any electricity. There are electricity generated, but so small, which we consider this as insignificant. Cannot be used to charge any battery or to light up any electrical appliances. So rain and clouds are the enemy of the photovoltaic technology. I mean the silicon-based technology. We need other type of technology. So how much power does the sunlight carries? It is P input. Power of an intense sunlight that could provide is 1000 watt per meter square. This is the input that God has given to us. In Malaysia, averagely we have 1000 watt per meter square during bright day. What happens if the intensity becomes lower due to cloud? The power of input will be lowered. And if it is low enough, no electricity could be generated. So P output, this one. When the sunlight, the 1000 watt per meter square has been absorbed by the solar panel, so depending on the efficiency of our solar panel, if the efficiency is 10%, so we only manage to get 100 watt per meter square during that time. So this is the P output. We have calculations. Fatin dah belajar tak dulu waktu buat FYP macam nak kira P out. Dia efficiency dah kira. Nanti lupa kan? Apa, tunjuk saya punya video dalam MOOC, nanti tahu balik. So P out is the power that we could harvest from the sunlight, depends on size and the efficiency of our solar panel. How to do the calculation? I have Excel slide after this. You could easily calculate the P out using that slide. So most popular silicon-based solar panel is from Venus Solar Power. You could visit this website. And these are the range of size and power output. Range of size of Venus solar panel. We have to see the size, the weight and power output. Why do we need to know the weight? Because sometimes we need to we want to attach the solar panel with our aquaponic system. So if the solar panel is too heavy, if we place the solar panel higher than the aquaponics, it is dangerous. Because wind might blow away our solar panel. Because they are in type of plane. So the it is less aerodynamic, so it is quite dangerous. The weight as well. So important parameters to determine spec of pump and solar panel. For an aquaponic system, factor of wind speed, sunshine, humidity and temperature will be minimized. Water is supplied 24 hours to the plants. Water level for plant is controlled by mechanically automated flushing system. This is our 1.0 prototype. In 2.0 prototype, we have eliminated this mechanically automated flushing system. We integrate the system with Arduino, Raspberry Pi. You know what is Arduino and Raspberry Pi? It's a microcontroller, small computer that will control the water level depending on the plant that you use for the system. Different plant will need different level of water, so we need microcontroller to control that. So parameters to be considered: the duration of pump. For example, if you need for 24 hours, you need to consider this into our calculation. How to calculate? I'll teach you after this. Density of water. Basically, if we use fresh water, about 1000 kg per meter cube. Height of pumping. Depending on your system, usually I will use 1 meter. Flow capacity of water during pumping, we need to calculate this one, depending on the plant. So this is the aquaponic system looks like. We have aquarium, we have hydroponic. Hydroponic plus aquarium, we got aquaponic. And we install the solar panel, could be like this or any design that you desire. And this is the cross-sectional area of the device. So this is the hydroponic part. We don't use soil or apa lagi kita pakai. Selain daripada soil, kita pakai apa? Hydroponic. Kapas kan, cotton kan? Sabut, fiber. Well, instead of soil and fiber, we use hydroton. This is ceramic ball. The ceramic ball, why do we use ceramic ball? Because if the ceramic ball is exposed to water, it has the tendency to grow algae. And that algae could be used as fertilizer for our plant. And how do we grow the algae? From the excrement of the fish in aquarium. The excrement, I mean the thing that they produce, the excrement, we will pump with the water and supply to the plants. And that will induce the growth of the algae in the hydroton. The spherical thing over here is known as hydroton, ceramic ball. If you want to buy, you could buy from the local supplier, ask them about hydroton, they will give you. And this is the mechanical flusher system. When the water has reached a certain level, it is automatically flushed out. I mean, just like our toilet lah kan? We have automatic flush, mechanical flushing system. When the water reach at this level, it will automatically flush out to the aquarium back again. So we need to pump the water to go inside the hydroponic system. And that pump need to be powered by our solar panel. And this is the height of pumping from the inlet to outlet. Remember height of pumping, inlet to outlet. Tak payah kira sampai sini, sampai sini. So these are the parameters: height of pumping, density we could calculate using density meter, or if you use fresh water directly, you could use 1000 kg per meter cube. Duration of pumping depends on your specification. How many hours do you want the pump to operate? Then, knowing this parameter, we could calculate the flow capacity of water. So using the available parameter, we could calculate the power of motor pump that we need. So we continue our lesson on solar powered aquaponic system. This is an application of the things that you have learned in photovoltaic in solar cell technology class to be applied in farming. This is one of the applications. So the farming system that I have chosen for this final chapter is the aquaponic project. So aquaponic is a combination of aquarium, where we put our fishes in the aquarium, and combined with hydroponic system. So as you can see from the picture here, we have the aquarium at the bottom of the prototype, and we have hydroponic system at the top of our prototype, and inclusive of the solar panel and the battery to power up the motor. Now, how do we calculate the specification of the motor ataupun motor? How do we calculate the specification of the motor? It is depending on this parameter: the flow capacity, the density of fluid, and the pumping height. The pumping height, as I mentioned yesterday, we need to refer to the prototype. For example, like this. If this is our prototype, so the height of pumping is from the inlet of the water from the aquarium to the outlet, which will flow through the hydroponic system. So this is the pumping height. So in this prototype, the pumping height is 1 meter. So we just need to key in 1 meter over here. Density of fluid, if we are using the fresh water, the density of fluid is approximately 1000 kg per meter cube. This is constant. We don't use salt water, right, to water our plant. We use fresh water, so it is equivalent or approximately 1000 kg per meter cube. And the flow capacity is depend on the plant. Some plant we need 200 milliliter per second. Different plant, they will need different value. So where could we refer to? So there are books already published by researchers. They have published each type of plant and the requirement of the flow capacity. You could easily, or you could just easily Google the value of flow capacity of any plant if you wish to do your own project. So I could give you the references for the flow capacity, but not during this course. I could give you anytime. You just need to request to me. So the flow capacity, which is usually published in books or journal, is in milliliter per second. So for my class, I will convert it to meter cube per hour. So how do we convert it? Using this equation. Just simply click. I will give you these notes, this Excel, but promise me that you won't distribute the notes, the Excel and also the PowerPoint slide to other person. It's for your own usage. It's for my student. Do not give to other people which is not belongs to my class. So it's simply just times 3.6 divided by 1000. This is the conversion factor from milliliter per second to meter cube per hour. So you got 0.72. So this is just an example. So from this parameter, the system will automatically, the Excel will automatically calculate the power, the specification of the motor which will pump the water. So the motor over here that we need is, the value is about 1.962 watts. And suggested power is that 3.92, which is times 2. Why times 2? Because the efficiency of the water pump will not be 100%. This is
assumption of 100% of efficiency. Any device, any man-made device cannot reach 100% of efficiency. So to be safe, times 2. Usually the maximum efficiency of any man-made device is about 50%. 50%. That is why I times 2 the specification of the calculated specification of the water pump. Instead of 1.96, I made it becomes 3.92. This is in watt, this is in kilowatt. How to calculate kilowatt? Just simply divided by this parameter. You could just simply click at the colored field. You could see the formula. Please memorize this formula. Yeah. Sorry, come again.
Click on the
Which one?
green.
This one.
Left.
This is how we calculate from this parameter. How to get the value of required specification of the water pump. So the formula is that D7 is this one, D7. The flow capacity times density of fluid times pumping height times 9.81 divided by berapa ni? 3,600,000. And you will get the value of kilowatt. This is how we get the kilowatt value from this parameter. And this one I convert it into watt by times 1000. This is kilowatt, this is watt. So you need to refer to the blue one in order to suggest the suitable water pump. Make sure you times 2 because we need to consider the efficiency of the water pump. It's not 100%, usually 50%, depending on the brand of the water pump. So this is constant density of pure water or fresh water, 1000 kg per meter cube. Assumption, this is assumption, water pump efficiency is 100%, but we need to increase the times 2 lah.
How about the below 50% efficiency?
If you have a big fund, if money is not of your concern, times 3. The more is better. Okay. Flow capacity, you could just simply change it 1200. Then the specification will change. But how about 600? Yeah. Now, so it is 11.77. But please remember, if you like this one example, you are suggested to buy 11.77 watt motor pump. But if you go to the hardware store and ask for 11.77 watt motor pump, you will be scolded by the shopkeeper. There is no such thing as 11.77. They only have 12, round number, 12 or at least 12. If they offer you bigger, for example 13, take it. So from the calculation of motor pump, we need to calculate the specification of the battery. The battery which will power up our pump. Now look at this tab. We have a tab for battery over here. Calculate, click it, and we got the tab of battery. So the input for the battery calculation is like this. We need to key in the power of pump. Example, we need to refer to the previous slide. The suggested power of pump is 11.77, approximately 12. Key in 12. Time of operation per day without charging. How many hours you want the pump to operate? This is just an example. The pump needs to operate for 20 hours non-stop. So for this case, the power consumption is automatically calculated about 240 watt hour. Simply by multiplying 12 and 20, you got 240 watt hour. This is the power consumption. The power that is being consumed by the water pump which will be extracted from the battery. We haven't reached the solar cell yet. After this, we are talking about the battery and the pump. So our battery must supply at least 240 watt hour per day. So how do we make sure that? Okay, now remember we need 240 watt hour. So we need to select our battery. From where can we select? There are many batteries in the market. These are types of battery. We just need to look at the voltage and amount of energy charge, AH. If you refer to your power bank, usually you will ask the shopkeeper, how many mAh is this power bank? It's not mAh, it's milliampere hour. There is amount of energy charge inside your power bank. So now, just look at these two specifications, and you could simply multiply voltage and ampere hour, you will get watt hour. Understand this? Still following me? This is the battery specification. This side is the water pump specification. After you have calculated these two parameters, you got that you need 240 watt hour to operate your water pump for 20 hours per day. And the power source is from the battery. You need to choose a battery that could supply to at least 240 watt hour per day. So you look at the list of which will be given by the shopkeeper. Just refer to the, forget about the dry weight capacity. Capacity, we need to look at capacity. Just look at the voltage and amount of energy charge, because multiplication of voltage and amount of energy charge, you will get deliverable power, the power that the battery could supply. Now refer to the power consumption again. We need 240, and if we use this type of battery, we could deliver 204,000. 2,400. Is that good? That is good, because after 1 day of usage, you still have 2,160 watt hour. There are still energy left in your battery. So why do we need this enormous amount of energy, of power? We only need 240. We could deliver 2,400. Why do we need such battery? Because during rainy days, we cannot charge our battery using solar cell. So we must have a contingency plan. We could not charge our battery daily basis. Sometimes during the rainy season, the solar cell doesn't work. We are using silicon-based solar cell. Plus, we only have 4 hours per day to charge. So as a contingency plan, we spare extra power in the battery. So we choose battery with higher specification to support the power consumption by the pump. So the balance after 1 day of usage, we still have 2,160 watt hour, which could be used for the next day. So if we want to operate the 240 watt hour motor, and we have 2,400, how many days can we use the battery without charging? 10 days without charging. So this is suitable for rainy days, because in Malaysia we have rainy season kan. So we need to think of that. So clear up to this level? Okay, good. So this is the tip. Generated power per exposure of solar panel in watt hour must be bigger than daily power consumption. This one, oh sorry, we haven't come to that part yet. Sorry, we are coming to that part. Okay, now after we have done calculating the water pump and battery specification, we need to look at the recharging, the solar panel. This is solar panel. So to study about this one, we need to click the solar panel specification tab over here. Click it. So remember, the needed power to recover per day is 240, because on daily basis we will lose 240 watt hour because of the usage of our water pump. So on daily basis we must be able to recover at least 240 watt hour. See, 240 watt hour. It is automatically calculated, not calculated, automatically keyed in by the system by referring to the previous slide. Let's say we change this one, 15, so we need 180, and it is calculated over here 180 automatically. So the color of the slides of the field has meaning. You must refer to the legends. I have put all the legends over here. Red means input, you need to key in. The things that you need to key in is colored in red. That are the only field that you need to key in. The other color automatically calculated by the system. Do not touch this field, including the output. Do not touch this field, and this is suggested value, and the gray color comparison is needed. So you just key in the red colored field. This is automatically calculated, and the gray field, this one and this one, they need to be compared. So the requirement is like this. This one must be greater than this one. This is the power used. This is the power being replaced by the solar cell, by the solar panel. This one must be greater, or at least equivalent. To be safe, must be greater, because our device is not 100% efficient. Must be greater. So how do we calculate? You need to key in this input. This is the solar panel specification, the power output and exposure to intense sunlight per day. Maximum per day in Malaysia is 4 hours. Put 4 hours. Power output, you have to refer to the specification of the manufacturer. They have so many lists of see, power output over here, 3, 20, 50. Just simply key in. For example, if you want, let's say, how about if we try to use this specification of solar panel? We put 3. So the power generated by our solar panel only 12 watt hour. Can we replace the power lost by the usage of the pump? No. We need 240. But if we use this panel, we could only generate 12 watt hour. So we need to key in one by one, looking for the suitable solar panel. How about 100? 400? That is even better. If you have so many money, fund, you just simply use this one. Or your budget is tight, 75 looks quite satisfying. We need 240. We could replace or replenish about 300 watt hour per day. So this one could be good for you. And the capacity of battery also automatically calculated. This is referring to tab battery spec H7. Battery spec H7 is this one. Yeah. So this is the correct usage of Excel. We don't use Excel for graph. This is the correct usage of Excel for automatic calculations. We don't need calculator. This is extra. So what is the meaning of green? I also can't remember, even though this is my own slide. Green output. Okay, green is output. So the output is that time of charging from 0% to 100%. How many hours do we need? 8%. 8 hours. If we use this specification, we need about 8 hours to recharge the energy loss. How to calculate? Click, you got the formula. F6 divided by E6. F6 is this one divided by E6. 2400 divided by 300, you got the time of charging. About 8 hours. If time really bothers you, so increase the power output. Change the specification to higher spec, you got 6 hours. Remember, we need 4 hours per day. It means that we cannot charge the battery to the full within 1 day, because time is our enemy. We only 4 hours, but we need to charge. If you use this spec, the charging speed is 6 hours. Increase the spec. How about 1 to 5? 4.8 hours, even better. How about 150? Ha! 150 seems good. But remember, this is from 0% to 100%. Sorry, I amend my statement. If your battery flat out, 10 days without light, your battery flat out 0%. So how many days you need to charge the battery? How many hours? If you use this pack, you only need 4 hours. You only need 1 bright sunny day. Because during rainy season, sometimes there will be 1 or 2 days with sunlight, right? It's not forever 3 months without sunlight. There will be 1 or 2 days with sunlight. So we need to extract sunlight during that interval time, during the sunny day in between the rainy season. So this pack is the best. 1 day. We only need 1 day in every 10 days of rainy season. Within 1 day, we could recharge our battery easily. Understand? So how many days? About 0.17 days. This is in hour, this in days. The formula is like this. Always refer to the formula here. So I don't give you, I will not give you the formula over here, how to calculate. You just need to click and find out your own formula over here. Same goes here. What is formula? Oh, in battery spec, H7, battery spec, H7. How to calculate this one? Click it, F7 times G7. F7 times G7. Oh, like that. That is the formula. Understand? So this is how you calculate the specification of solar panel. So now we need to compare the gray field. Generated power per exposure 600. Needed power to recover per day 240. Is this meet the requirement? Are these values meet the requirement? This one? Yes. Because the needed power to be recovered per day must be smaller than generated power per exposure. This one is smaller than this one. This is good. We generate exceeding the expectation. So again, if your budget is tight, you could always lower down the specification. So if you use 125 watt, you need 4.8 hours to recharge from 0 to 100%. If 75, it's about 8 hours. So you need 2 days. If your budget is tight, you can use 75 watt, but you need 2 sunny days to recharge your battery from 0 to 100%. Understand? Now, let us calculate the cost. The cost. Simple. This is for a DC system. We have 2 systems of solar panel system. We have DC, we have AC. Usually we will go for DC because it is cheaper, plus the electronic appliances, because we have PWM. I will show you what is PWM later. We have some electronics which the DC based electronics is much more reliable. I mean, the lifetime of DC based electronics is stronger. So always choose DC system. So okay, if you want to use the 75, this is automatically calculated depending on, so for example, you click 75, it is referring to tab solar panel spec, C6 solar panel spec, C6, this one. The thing that you key in here automatically key in over here, and automatically will give you the cost for the unit. You just need to key in how many unit do you need. If 1, click 1. This is the cost. Battery automatically detected by your previous slide over here, by your previous Excel over here, automatically calculated. So this is the total cost needed for one DC system. And this is the total cost for one AC system. The price is over here. You could always change the price. I mean, the price will be fluctuated depending on the price of oil. Why? Because people send all their goods and transportation using petrol. So the price will be fluctuated. You can always change the price over here and automatically will be calculated over here. Just need to change the price here in this field. Understand that one? Okay. Now, why in the world you could see formula in this price? Nak kira price pun ada formula. Because this is projected value of this model, of this battery. Why I use projected value? Because value will be changed over time. This is, see, the trend of price of the material. You don't need to memorize this. I won't ask this trend. This is just for my hobby. I predict price of battery and solar panel using this graph. If you want to learn how to do this trend, just use this Excel. Do your own study. Now let us see the complete system. This one. So this is how the DC based system look like. We have solar panel. We have pulse width modulator. This is known as solar panel controller. To set time of usage. Timer. Let's say you want the DC pump to operate for 20 hours, you could set using this PWM.